Part 1. A relatable introduction that sparks curiosity. Have you ever been in a situation where you really needed your smartphone, but the battery was at 1%? Or maybe you were on a long trip, and your power bank became your lifesaver. We all depend on batteries every single day. From digital watches, electric vehicles, to the laptops we use for work or study. But have you ever actually stopped and wondered, how do batteries really store energy? How can such a small object power something so complex? What's interesting is, the concept of batteries is not new at all. Hundreds of years ago, humans were already trying to store energy in a reusable form. And today, batteries have become the backbone of modern technology. From electric cars to renewable energy systems, everything relies on the ability to store and deliver energy. In this video, we're going to explore the world of batteries. Not just a simple definition, but how energy is stored, transferred, and finally used by our devices. We'll look at it like a story about how energy travels from one form to another until it becomes something useful for us. And maybe after this, you'll never look at batteries the same way again. Part 2. The basic principle explained simply. Imagine you have two containers of water. One is full, and the other one is empty. When you connect them, water flows from the full one to the empty one. A battery works in a similar way. But instead of water, what flows is electrons. Inside a battery, there are two main parts. The first one is called the anode, and the second one is the cathode. Between them, there's a special substance called the electrolyte. The anode is where electrons gather. The cathode is where they want to go. When you turn on a device, electrons start moving from the anode to the cathode. This movement creates electricity. And what's crazy is, all of this happens on a very tiny scale. We're talking about particles that you can't even see. But the impact is massive. In just one small battery, there are billions of electrons moving every second. And all of that happens almost instantly. That's why batteries look simple, but are actually incredibly complex. Part 3. How energy is actually stored. Now let's go a bit deeper. How is energy really stored inside a battery? Energy in a battery is not stored as electricity directly. It's stored as chemical energy. When you charge a battery, electrical energy from outside is converted into chemical energy inside. This energy is stored through chemical reactions between the anode and the cathode. For example, in a lithium-ion battery, lithium ions move from the cathode to the anode while charging. And when you use it, they move back to the cathode. This movement creates a flow of electrons outside the battery, which we use as electricity. Think of it like a compressed spring. When you charge a battery, you're basically compressing that spring. And when you use it, the spring releases energy as it returns to its original state. That's why batteries run out, because the chemical reaction reaches a balanced state. And that's also why they can be recharged, because we can reverse that whole process again. Part 4. Real-life examples you see every day. Now let's look at real-life usage. The most obvious example is your smartphone. Every time you open an app, watch a video, or play a game, your battery is working behind the scenes. In a single day of normal use, millions of chemical reactions are happening inside your battery. Another example is electric vehicles. Electric cars use large batteries that can store huge amounts of energy. A modern electric car can store energy equivalent to many liters of fuel. But instead of burning it, it delivers energy as electricity. That makes it much more efficient and environmentally friendly. Batteries are also used in renewable energy systems, like solar panels. Energy from the sun is stored during the day and used at night. Without batteries, that energy would just go to waste. So you can think of batteries as a bridge between energy production and energy usage. Part 5. Common mistakes people make. A lot of people still misunderstand batteries. For example, some think you should always charge your battery to 100%. But in many cases, keeping it around 80% is actually healthier. Some people also believe you should let the battery drain completely before charging. That might be true for older batteries, but not for modern ones. Another mistake is overcharging. Even though modern devices have protection systems, this habit can still slowly damage the battery. Temperature is also a big factor. Batteries that are too hot or too cold lose performance faster. That's why many devices have cooling systems built in. Understanding these things can help extend your battery life and keep it performing well. Part 6. The future of battery technology. Now let's talk about the future. Battery technology is evolving fast. Scientists are working to make batteries lighter, stronger, and longer lasting. One of the innovations being developed is solid-state batteries. These batteries use solid materials instead of liquid electrolytes. The result is safer and more efficient performance. There's also research on batteries that can charge in just a few minutes. Imagine charging your electric car in less than 10 minutes. There are even concepts of batteries that can last for decades without replacement. All of this shows that batteries are not just supporting technology. They are becoming the foundation of our energy future. And maybe one day, we won't even worry about running out of battery, because technology will have moved far beyond what we can imagine today. Closing. Now you know that a battery is not just a simple object. Inside it, there's a complex world working non-stop. From chemical reactions to electron movement, everything happens with incredible precision. And all of it has one purpose: to give us energy whenever we need it. If you enjoy content like this, click the subscribe and like button to support this channel, and share it with your friends who need this kind of insight. Part 7. What really happens when a battery degrades? Now here's something most people notice but rarely understand deeply. Why do batteries get worse over time? At first, your device lasts all day. But after months, maybe a year, it starts draining faster than before. This is what we call battery degradation. And it's not random. It's a direct result of what's happening inside the battery. Remember the chemical reactions we talked about earlier? Every time you charge and discharge, those reactions are repeated again and again. But here's the thing. They're not perfectly reversible. Over time, small side reactions happen. These reactions slowly damage the internal structure of the battery. For example, in lithium-ion batteries, a layer forms on the anode surface. This layer is called the solid electrolyte interface. At first, it actually helps stabilize the battery. But as it grows thicker, it starts blocking the movement of ions, which means less efficiency and less capacity. It's like a road that slowly gets clogged with traffic. Cars can still pass through, but much slower than before. That's why your battery can no longer hold as much energy as it used to. And this happens no matter how careful you are. But the speed of degradation depends on how you use it. Part 8. Fast charging and its hidden trade-offs. Fast charging sounds amazing, right? Plug in your phone for a few minutes, and suddenly you have enough battery for hours of use. But behind that convenience, there's a trade-off happening. Fast charging pushes energy into the battery at a much higher rate. This creates more heat. And heat is one of the biggest enemies of battery health. When temperatures rise, chemical reactions inside the battery become more aggressive. This can lead to faster degradation. In some cases, lithium can even deposit as metal instead of ions. This is called lithium plating. And it's bad news, because it reduces capacity and in extreme cases can cause safety issues. Think of it like pouring water too fast into a sponge. Instead of absorbing smoothly, it overflows and creates imbalance. That's why many modern devices use smart charging systems. They slow down charging when the battery gets too full or too hot. So while fast charging is convenient, using it all the time might shorten your battery's lifespan. Part 9. Why battery percentage is not always accurate. Have you ever noticed your battery drops from 20% to 0 really quickly? Or sometimes it stays at 100% for a long time, then suddenly drops. That's because battery percentage is actually an estimate. Your device doesn't directly measure how much energy is left. Instead, it calculates it based on voltage, current, and usage patterns. Inside your device, there's a system called a battery management system. This system constantly monitors the battery's condition. But as the battery ages, its behavior changes, which makes predictions less accurate. It's like trying to estimate how much fuel is left in a tank, but the tank itself is changing shape. That's why sometimes your battery indicator feels unreliable, and that's also why calibration can help improve accuracy. By occasionally letting the battery go through a full cycle, the system can recalibrate its estimation. Part 10. Energy efficiency and why it matters. Now let's talk about something that most people overlook. Energy efficiency. It's not just about how much energy a battery can store. It's also about how efficiently that energy is used. Every time energy moves in or out of a battery, some of it is lost as heat. This is unavoidable. But better battery design can reduce these losses. For example, high-quality materials allow ions to move more freely, which means less resistance and less energy wasted. This is especially important in large systems, like electric vehicles or energy storage for homes. Even a small efficiency improvement can make a huge difference. Over time, it can save massive amounts of energy and reduce environmental impact. So when people talk about better batteries, it's not just about size or capacity. It's also about how smartly energy is managed. Part 11. The invisible role of battery management systems. Let's go deeper into something you never see, but always rely on. The battery management system. This system is like the brain of the battery. It controls how energy flows, how the battery charges, and how it protects itself. Without it, modern batteries would be far more dangerous. The system monitors temperature, voltage, and current in real time. If something goes wrong, it can shut everything down instantly. It also balances the cells inside the battery. Because in large batteries, not all cells behave the same. Some may charge faster, others slower. Without balancing, this could lead to uneven stress and early failure. So the system constantly adjusts to keep everything stable. It's like a conductor leading an orchestra, making sure every part plays in harmony. And even though you never see it working, it's essential for everything to function safely. Closing. At this point, you're not just looking at batteries as simple power sources anymore. You're seeing them as complex systems full of chemistry, physics, and smart engineering. From how energy is stored, to how it flows, to how it slowly degrades over time. Everything is connected. And the more you understand it, the more you realize how important batteries are in our daily lives. If you enjoy content like this, click the subscribe and like button to support this channel, and share it with your friends who need this kind of insight.